Okay, so a cup of hot chocolate is left on the table. The number of degrees above the room temperature of the hot chocolate is given by this equation, where T is the number of degrees above room temperature, and M is the number of, like the time in minutes the cup was left on the table. M is your X variable, so you're gonna say minutes goes, right, like your coordinate. Minutes is first, and then temperature is next every time. I think it's probably a good idea to do that. As well, what do we imagine here? This is A and this is B. We know that this starts somewhere at 068.28. Sorry, it's crowded there. And what's happening? Is it going up from there or is it going down from there? Down. I know that because this is less than 1, right? So it's like this. So all of these things could have been deducted just by looking at it. So let's enter it into our calculators if you haven't done so already. Some of you are hard at work, and some of you are hardly working. Did he just say that? Yes, I did. Okay, my window. I'm gonna go and say that my Y max, I'm gonna go to like 70 because I know I start at 68 and I come down from there. So that's for sure. I'm gonna try this, let's give it a try. It's actually pretty good. Is this ever touching the x-axis? Does this line ever touch the x-axis? Never. There is a horizontal what? Asymptote. Yeah. Okay, you are awake. Sometimes I'm like, are you guys listening? Okay. Okay. We got that. Make a graph of the number of degrees above the room temperature as a function of time. This is where students struggle with this. The struggle is real, okay? But don't fear it too much. So let's go with A here. I would prefer a ruler, not just some dog's breakfast thing. Okay? So this is time in minutes. This is temperature in degrees Celsius. Okay, so you've got that. For my Y, I'm gonna go up consistently, and I wanna go all the way up to 70. So let's see if I can make this work here. 10, 20, 30, 40, 50, 60, 70, 80. That seems to work right there. Now keep in mind, most of the time I will be giving you a grid so that you don't have to worry about the spacing, but it should be a consistent spacing. Now this is the problem. Students struggle with, what do I do here, right? And so maybe sometimes you just need to keep answering questions. But I know for sure this is 60, 68 is right about there. I know I'm going from there down like this, okay? So let's answer a few more questions. B, determine how long it will take for the temperature to cool to 20 degrees above the room temperature. Okay, so it's asking how long when I'm 20 degrees above, and it matches the wordings, right? So it's not just saying when is it going to be 20 degrees, it's saying 20 degrees above room temperature, so we can confidently say this is 20. Y2 is 20, second, trace, intersect. I'm going to go doctor's note today, okay? That gives me, if I type that in, that is 17.46 minutes. That is absolutely a point that you can now use as part of your graph. Okay, so I'm going to go 17.46, 20 is a point. I'm going to put that down as well. Let's keep answering. What is the actual temperature of the hot chocolate in 30 minutes if the room temperature is 20 degrees? Oh, that's news. They finally tell us what the room temperature is. Okay, so we'll answer that. Let me just bring this down. C, I will answer that here. So they're saying when 30 minutes have gone by, how many degrees above are we? That's step number 1. And then second step will be 20 degrees plus whatever T is, right? Whatever we find this to be. That's the actual temperature of our hot chocolate, okay? So let's go ahead and find this. X is given, so second, trace value 30. There it is. Y is equal to 8.28 degrees Celsius. So we're going to say 20 plus 8.28. So we're going to say 28.28 degrees Celsius. It didn't ask for temperature above, it asked for actual temperature. So there we have it. And this is where I really wanted you to hear the word half-life. Okay? D. Make sure you highlight the word half-life. Okay? We're going to come back to that next week. But initial, what is our initial temperature? Like initial temp above is 68.28 degrees Celsius. Yeah. Because this is the actual temperature of your hot chocolate, but if you just go by T, you're at 8.28. This is, yes, because this is comparing not the actual temperature, but the temperature above room temperature and time. That's what we're graphing here. So this question just went a little step above. It's a good point, actually. Don't mix that up, yeah. So this is the one we would want to, this is the pair that we would want to plot. On a Friday, I get awesome questions like that. Okay, initial temperature. So half-life, okay, what is that? We let Y2, guess what? Instead of doubling time, you're doubling, right? Half-life, you will half it, okay? Which is what, 34.14? And then we go second, trace, intersect. Let's go ahead and find out what that is. 34.14, boom. 9.86 minutes. Why can I not say doubling time in this scenario? Is my temperature doubling every? No, it's always going down, right? So what does half-life mean? That every time 9.86 minutes have gone by, I'm going to go down to half of what I was before. And then half, and then half, and then half. So I'm always going, I'm actually shrinking, right? Every 9.86 minutes. So temperature drops by half every 9.86 minutes. That's important. That's the definition of half-life. What's the domain and range of this function? Would the hot chocolate keep dropping non-stop, or does it stop cooling off at some point? Stops cooling off when it's 0, right? Like, sorry, when it's 0 degrees above the room temperature. Like once you get to your room temperature, you stop, right? Do we have a problem here?
Oh,
because then if t is 0, that means that we're hitting the x-axis. It can't go to 0. So what are we going to say? For domain, we can go from 0, right? 0 to, when do we get to room temperature? Let me check here real quick. This is not a very good question for domain and range. So instead of confusing you, we're just going to say omit. Because there's a bit of a problem here. Because if t is 0, because 0 degrees above room temperature, then you're in trouble, right? And we're saying there is a... So just omit. This is not a good one. But let's graph this now. Oh, you're already ready to go home, right? How far do we go here? What's the furthest we have currently available to us? I would argue 17.46. So I'm going to go 5, 10, 15, 20. 17.46 is right about there, 20. And I also have 30. Oh, that's even further, hold on. 30 is 8.28, which is right about there. That's this point right here that I found. So technically here, I have everything I need, and then just go arrowhead. Like that. Okay. I don't like this question because eventually you will be 0 degrees above room temperature, right? At some point that hot chocolate will be the same as your room temperature. That's just a reality. So I should have probably stopped it a little sooner. It's like, just remember, this model stops, you know, at a certain time. It's only valid for the first 20 minutes, let's say. But I didn't. So for now, I hope that half-life is something that you will remember how to find it, and also how to do your graph. Like, just find some points. Some of you use second trace value, and you just type in any of these points along to help you determine the shape. Thank you, guys.